Next problem. The input to the RC filter is a white noise process with autocorrelation function Rxx of tau, which is equal to n0 by 2 delta tau. If the frequency response h omega, which is equal to 1 by 1 plus I omega RC, find the autocorrelation and the mean square value of the output process y of t. So given Rxx of tau, which is equal to n0 by 2 delta tau, that is equation number 1. Given frequency response h omega, which is equal to 1 by 1 plus I omega RC, we are multiplying numerator and denominator by its conjugate of 1 plus I omega RC, that is nothing but 1 minus I omega RC. So in numerator you will get 1 minus I omega RC. In the denominator we are using a plus b into a minus b. A, which is equal to 1, and b is nothing but I omega RC. So a square minus b square. So a square 1 square you will get 1 plus b square minus b square, that is minus I omega RC square. So I square is minus 1. So minus into minus plus omega square r square c square in denominator. That is equation number 2. Now the conjugate of h omega is h star omega. That is nothing but the conjugate of equation number 2. So conjugate means you have to change the sign of the imaginary part. So you will get 1 plus I omega RC by 1 plus omega square r square c square. That is equation number 3. We know s yy of omega, which is equal to modulus h omega square s xx of omega. H modulus h omega square is nothing but h into h conjugate, right? H star s xx of x. So we know the value of h of the omega and h star of omega from 2 and 3, equation 2 and 3. So we are substituting the value and then s xx of omega. So we are multiplying the numerator. So you will get again a minus b into a plus b. You will get 1 plus omega square r square by r square c square. The denominator you are multiplying the same term. So that is 1 plus omega square r square c square, the whole square s xx omega. So we are cancelling one term out of 2. In denominator you are having square, right? In numerator the same term. So we are cancelling. You will get 1 by 1 plus omega square r square c square into s xx of omega. Therefore s yy of omega, which is equal to 1 by 1 plus omega square r square c square s xx of omega, equation number 4. We know sx is the Fourier transform of rxx. So we are applying. So Fourier transform of rxx tau, which is equal to Fourier transform of given rxx tau is equal to n0 by 2 delta tau. So we are applying a Fourier transform of n0 by 2 delta tau. n0 by 2 is a constant we are taking outside from the Fourier transform. Fourier transform of delta tau, which is equal to n0 by 2 integral minus infinite to plus infinite delta t e power minus I omega tau d tau is equal to n0 by 2 e power 0, right? That is nothing but e power 0. That is equal to, right, and the e power 0, because we know integral minus infinite to plus infinite f of tau delta tau d tau is f of 0. So right here f of tau is e power minus I omega tau. So e power 0. So you will get 1, that is equal to n0 by 2. Therefore s xx omega, which is equal to n0 by 2, that is equation number 5. Some from 4 and 5 we will get s yy of omega, which is equal to 1 by 1 plus omega square r square c square into n0 by 2, which is equal to n0 by 2 r square c square. We are taking r square c square outside in the denominator. 1 by r square c square plus omega square, right? So s yy of omega, which is equal to n0 by 2 r square c square 1 by omega square plus 1 by rc the whole square. So f of r yy of tau s is nothing but Fourier transform of r. So f of r yy of tau, which is equal to n0 by 2 r square c square 1 by omega square plus 1 by rc the whole square. Taking inverse Fourier transform on both sides. So f inverse of f, it will get cancelled. You will get r yy of tau, and the right hand side f inverse of n0 by 2 r square c square into 1 by omega square plus 1 by rc the whole square. Here n naught by 2 r square c square is a constant. Take it outside from f inverse Fourier transform inverse. So you will get n naught by 2 r square c square f inverse of 1 by omega square plus 1 by rc the whole square. That is equal to n naught by 2 r square c square. Applying f inverse formula, we are using f inverse formula. That is equal to 1 by 2 pi integral minus infinite to plus infinite e power I omega tau by omega square plus 1 by rc the whole square d omega, right? That is equal to n naught by 2 into 2 4 pi r square c square. So pi by 1 by rc e power minus 1 by rc modulus tau. Since the integral value integral minus infinite to plus infinite e power I omega t by omega square plus a square d omega is equal to pi by a e power minus a modulus tau. Here a is nothing but 1 by rc. We are replacing that one, so you will get the integral result. So n naught by 4 r square c square into rc, 1 by rc become rc, right, in the numerator, into pi, right, e power minus 1 by rc modulus tau. Pi get cancelled, right? So you will get in the previous step n naught by 4 r square c square rc, there is no pi, so that is typo error, e power minus 1 by rc modulus tau. That is the ry by f tau. That is sixth equation. To find the mean square value of output e y square tau, we know e y square tau is nothing but ry by f 0, right, from the formula, which is equal to, replace tau by 0, you will get n naught by 4 rc e power 0, that is equal to n naught by 4 rc, right? Thanks.